Okay, so good. So this video would talk about how the design of the system, and how it supports technical, syntactic, and semantic interoperability, and how it supports multiple languages. So this is the server, right? This is the hub. Now the hub follows the multi-reactor model. So each one of these circles here, each one of these circles, this one, this gateway layer, and this remote database repository, each is actually represented on its own event loop, all connected by a single event bus, right? Now the good thing with the multi-reactor model is that when the saturation point of any one of the event loop is met, you can always spawn up a new one. So it can easily scale horizontally. So let's say, for example, the system is quite busy and there are a lot of object remote calls, which means that the object manager would have a whole lot of requests. Now, when the performance level of the object manager drops below that particular point, you could always create a spin up a second object manager, and that would get performance back to the appropriate level. Also, the difference between this and like a standard MVC is that there is no central hub. So even in this diagram, when you picture the gateway layer, everything is connected. That is just the instantiation of these objects, of these events of these services. Since each of them will be registered to an event bus, with a multi-reactor model, each can communicate with each other across the event bus directly. Alright, so the application registry, for example, will be listening on a bunch of endpoints, and those endpoints can be interfaced by any of the other services. The second area where scaling is going to be important is on the producer side, for when the producer is receiving requests from multiple applications. So let's go over to the producer, right? So remember the application router from the previous video and the object store manager. This is right here. So what simply happens is that when a method call comes in, it goes into the object store manager after being routed, and each call is executed on a separate worker, right? So this way, you're going to ensure that the producer isn't going to be easily saturated. Also, if that saturation is an issue, you can always create additional workers to ease the load. And you also notice that the store here, which would store all of the remote resources, is completely separate from the rest of the producer. This would mean that if I'm using the producer application as a user, as unit of the application, I could still expose it as a on network without receiving any conflicts between the local and remote data. Now the new system includes a bunch of other stuff that is not a part of REST. For example, that has to be built from scratch, such as the object exporter, the protocol manager, the network manager. This thing pulls the entire new system together, but all of these things are generic, and it could be extracted to a single reusable library, just as all REST systems are. But due to time constraints, I wasn't able to get this to a separate library. Alright, so the first thing, technical, syntactic, and semantic interoperability. Now, for those to work, all is required is that for an application to be able to tell all the other applications on the network how it interprets data, what environment it runs in, and how it interprets that environment. So this is where the idea of the application profile comes in. So with the application profile, what the application is simply going to do is that when it connects to the network, it will tell every application on the network by posting the application profile to the hub, what it can do, how it represents data, and which environment it runs in. Alright, so that is going to be handled right here. Cool, good. Now let's say this application, for example, um, is written in Java, right? So one of the things this application could do, this application could check to see whether the server supports Java by checking the server interface. So the server interface can tell the other applications what the server can do, and where the application profile is for one application to tell the other applications what it could do. So let's say, for example, this application implemented some standard way of representing a table, and it says, okay, it's a produced on this, and it represents this standard way of representing a table. Then any application that is a consumer could simply tell the hub, okay, I'm looking for any producer that represents a table following this structure, and then they will be able to interface. The next thing is how interfaces are exported without the need for IDL. So IDL is the way Coreblood does its interface definition. Now, in order to do that with this system, you don't need to know IDL, right? You don't need to know any IDL. So it uses YAML instead. So all of the data types that you could represent in YAML, which would mean all of the different primitives, any collection type and any combination of those collection type that would be legal in YAML would also be legal with this system. So how do you define interfaces? Well, you define interfaces the same way you would define a class in your language. That's it. So the only rule is that you would need a no argument constructor. That's it, right? And all private variables or remote interface will be converted to public. So, for example, if this was private instead of public, the hub will just convert it to public, right? So this is a remote interface, right? Which means that all of these calls would be remote calls. The second type of interface would be a bean or a pojo. Now, in this case, these are going to be the local calls. So nothing here is going to be remote. All of this stuff will be local. Now the benefit of this is that the consumer application can program their application against this structure, which would make it more interoperable with the producer, right? So this system here must also be quite simple. You could only use things that can be done using a bean or an pojo. That would mean variable declarations, getter and setter, and a no argument constructor instantiating those variable declarations. And that is it. So this, for example, can contain custom objects as well, for as long as all of those custom objects are either beans or remote interfaces. So this is how it gets rid of ideas. So for example, if this was a Scala, then this would just be however you represent an object class in Scala. If it was JavaScript, it would be just however you represent a class in JavaScript. So that way the person who's using the system won't have to go and learn anything they don't already know. All they would need to know is that it supports the primitives of YAML and the collection types of YAML. And if you're too bogged down to go and learn the collection type of YAML, it just sets, lists, and maps. You could always just use your custom objects. Just make your own thing and just use that instead. So now the next aspect is, so in the next video we'll just give you a demonstration.